Okay, so for the second piece of instruction for this, remember yesterday we just went over just basics with monomials divided by monomials, just to kind of review how fractions work. Today we're going to get into much more sophisticated polynomials in the numerator and denominator. So we're just going to jump right in. So example 1, and this is simplifying. Sorry, I should have said that first. Simplify. Example 1. If I have x squared minus 2x minus 15 divided by x squared minus 9. Okay. So the first thing I want to do here is factor. Now, a common thing that people want to do, which kills math teachers, is you want to just cross off the x squareds. But we can't do that because these are being subtracted and this is division. And subtraction and division do not cancel each other out. So we cannot do that. If this were multiplication, we could do that because you can multiply and divide and they undo each other. But we cannot do that with subtraction and division. So instead what I'm going to do is I'm going to factor the top. So thinking about my diamond, this is -2, this is -15, this is going to be -5 and +3. So x minus 5 and x plus 3. And then in the denominator, this is a difference of perfect squares. So remember that means the middle term would be 0, -9, so this is +3 and -3, which gets me x plus 3 and x minus 3. Okay, so now this whole thing is being multiplied by this whole thing. This is multiplication here. So now I can undo it with division. So I can cross this whole thing and this whole thing. Okay, again, because these are just two chunks of things being multiplied, as long as I take the whole chunk, I can divide it and make 1. So this equals x minus 5 divided by x minus 3. Now again, you're going to be tempted to see x over x and cross it off, but you cannot do that because this is subtraction. So that is in fact your answer. All right, let's do another one. Example 2. So this is 2x squared plus 10x divided by 3x squared plus 16x plus 5. Okay, so again, we have addition happening and division. We cannot simplify that yet, but we can factor. So on the top, on the numerator, my greatest common factor for these two terms is 2x. So I'm going to factor out a 2x, and in this first term, I'm left with x, and in the second term, I'm left with 5. So there's my factored numerator. In the denominator, I'm going to factor, and I can use my diamond. So I have 16, and then remember, because this is not 1, this is a 3, I have to multiply these together. So this is 15. And then two numbers that multiply to make 15 and add to make 16 would be 15 and 1. So then if I do my box, I have 3x squared and 5, and then I have 15x and 1x. My greatest common factor here is 3x, and 3x times x, and 3x times 5, and then here my greatest common factor is 1. So 1 times x, 1 times 5, that works. So now this factors to be 3x plus 1 times x plus 5. All right. Now I see I have an x plus 5 and an x plus 5. So those are the same. This is all multiplication, right? We've divided it, or we've broken it into multiplied pieces. So I can cancel those out. That makes 1. And so now I have 2x over 3x plus 1. And I am done. That's all I can do. And so that's my answer. Okay. So then, let's say I want to multiply some rational functions. To multiply, so let's say I have 3x minus 3x squared divided by x squared plus 4x minus 5 times x squared plus x minus 20 divided by 3x. Okay, so the first thing I want to do is factor all of this. So in this, the greatest common factor is 3x. So I get 1 minus x. Down here, if I make my little diamond, it's 4 and negative 5. So it's going to be 5 and negative 1. So x plus 5 and x minus 1 times up here I have 1 and negative 20, so that's going to be positive 5 and negative 4, x plus 5, x minus 4, and then down here I have 3x. Okay. Now I can start canceling things out. So I have an x plus 5 and an x plus 5. I have a 3x and a 3x. Remember, what's on top has to match what's on the bottom. Now here's a tricky thing here. These do not quite match, but if I factor out a negative 1 here, this would be negative 1 times negative 1 plus x, which then, can you see this is the same, positive x and negative 1. So now I can factor, or I can cross those out, but I'm left with this negative 1. So this is negative 1 times x minus 4 in the numerator, and the denominator is all gone, which means it's 1. Anything divided by 1 is itself, so I don't have to worry about that. So now I can just distribute my negative 1, and I get negative x plus 4 as my answer. Let's do another example. So if I have x plus 2 divided by x cubed minus 27 times 2x squared plus 6x plus 18. Okay, and in this case, this isn't a rational function, it's just a polynomial, but that's okay because I can just put a 1 under it and proceed. All right, so I'm going to factor first. This numerator, there's nothing I can factor, so that's going to stay the same. This denominator is a difference of perfect cubes, so I'm going to use that pattern. And let's over to the side here just quickly review all of our special patterns. This is a good time to do that. So if I have a squared minus b squared, that factors to be a plus b times a minus b. We went over this multiple times earlier in the year, so I'm not going to spend a lot of time on it, but it's good to just remind ourselves what these patterns are. So if I have the sum of perfect cubes, that's going to be a plus b times a squared minus ab plus b squared. And if I have the difference of perfect cubes, like I do in this case, it's going to be a minus b times a squared plus ab plus b squared. So there's my special patterns. Okay, so thinking about this last special pattern and looking at this, my a equals x and my b equals 3, right? 3 times 3 is 9 times 3 is 27. So this is going to be x minus 3 times x squared plus a times b is 3 times x plus b squared, 3 squared is 9, times, and now here I'm going to factor. The first thing I notice right here is that I can factor a 2 out of all of these. So 2 times x squared plus 3x plus 9, and all over 1. And this is beautiful because this whole thing here and this whole thing here cancel out. So I am left with x plus 2 times 2 divided by x minus 3 times 1 we don't need. So that is our answer. All right. Now we're just going to do a little division and then we'll call it good. Oops, looks like I need some space. Division. So here's our first example for division. Just thinking about regular numbers. Oh wait, we already did that yesterday. We don't need to do that example. Sorry about that. Okay, so 7x divided by 2x minus 10 divided by x squared minus 6x, all divided by x squared minus 11x plus 30. Okay, so there's our problem. So if you remember from yesterday, when we're dividing, we keep the first one the same. We change the division to multiplication, and then we're going to multiply by the inverse. So we're going to flip the second fraction. Okay, so now I've done that. Now I'm ready for multiplication, and then we're going to do the rest of the steps just like we did for the last one. So I'm going to factor. 7x can't be factored, so we're going to leave it. This is 2 times x minus 5. This, let's make our diamond, negative 11 and 3. Oh, I wrote this wrong. Huh, look at that, it's 30. Sorry about that. Okay, So then we have negative 5 and negative 6. So this is going to be x minus 5 times x minus 6. And then down here I can factor an x out of both of these, so x times x minus 6. So x minus 5 cancels, x minus 6 cancels, x cancels, and I am left with 7 halves. Oh, I love these. I find it so satisfying to take something so messy and get something so pretty and simple. Okay, and we are going to call that good.